Hello everyone, this is Ashur here again. Welcome back to my channel. Today, in this video, we will talk about RF survey and its two methods with a quick overview on the differences between them. So before we start, please notice that I have decided to limit the theoretical content presented in this session, leaving more rooms available to focus on the practical side. So I'll dive deeper in a demo using Ekahau site survey software for one of the WLAN challenging vertical markets and try to predictively design Wi-Fi for a concert hall. It's a facility of my choice that I'll take advantages of in order to introduce Ekahau interface and how you can import AutoCAD layouts using the WOW feature. Also, I'll touch base on the right approach on how you can select the right AP and antenna for the environment you wish to design for. Moreover, I'll showcase on how to either manually design it for yourself or just rely on Ekahau Auto Planner feature to do it for you. Last but not least, Ekahau has a plenty of data visualizations available. We will examine most of them and see how we can interpret these data visualizations. Okay, let's move on. RF survey. Actually, there are plenty of ways you can define the term RF survey. I have included a brief one here for you, but in brief, the way I see it, it's a procedure followed by Wi-Fi engineers to identify the number of required access points to be deployed in a facility, not only to provide wireless coverage or an adequate coverage, but also to satisfy the capacity requirements as demanded by the wireless stations in that facility. Here, I have referenced two main keywords, coverage and capacity. Let's talk about coverage. It can be thought of as the availability of RF signal everywhere in the site as demanded by wireless stations for the sake of having them connected to the Wi-Fi. The other term is capacity, which is all about the number of devices that will be connected to the Wi-Fi and the applications running on them. Why do we care about applications? Well, some applications are bandwidth greedy and others are bandwidth light. So you have to consider creating a bandwidth contract per station, then accumulate that for all your stations to come up with a capacity forecast that you could use in your design. Now, everyone should be well aware that we are not only confined to both coverage and capacity as the only design requirements. These are conventional design requirements that are expected to exist in every Wi-Fi design nowadays. However, there are many other unconventional design requirements, and that depends on the environment type you're designing for. Let's take this office space. It's a nice office with a nice view, but there's a small concern by your customer here. The customer policy doesn't allow mounting access points on the ceiling, but the customer wants to have this office or all other offices like this covered with Wi-Fi. So you're only left with mounting the access points above the ceiling. Now, this is an aesthetic design requirements and it changes the whole design. So you should include it in your design requirements. Mounting the access points above the ceiling will change the coverage pattern of the access point. And the signal will be degraded based on the attenuation incurred by the ceiling material type. So, as you noticed, many design requirements could rise up during the design process. We need to take care of all of them in order to provide a design that meets the customer requirements. Okay, so as outlined in our agenda, predictive RF survey is the first method used to design Wi-Fi. It's a software-based design approach, and it takes advantages of the facility layout that was provided by your customer. You can simply add this layout to your site survey software and define your design parameters that you wish to achieve, and simply with a few clicks, boom, you are covered. That sounds simple, right? Not really. We will see its ups and downs in our demo. As you can see, predictive RF survey can be done in two ways. One without visiting the site, and the second one with some on-site activities. So what are the differences between the two approaches? For the first one, we assume that the site structural elements inside our coverage area are made of well-known material types that have predefined attenuation values. What does that mean? That means, for this wall, we consider it, for example, a concrete wall. For others, we can consider them glasses. If we go into Ekahau site survey, we can see it has multiple material types along with its or the corresponding attenuation value per material type. So we have classified in our layout that we want to use concrete here, we want to use brick wall here, we want to use marble, we want to use window, etc. We use Ekahau to draw these material types, and then we start placing our access points in order to get the coverage model. So without visiting the site, we just rely on the predefined values. But bear in mind that these predefined values might not fit the site you're designing for. In the second method, we actually visit the site for two reasons. The first one, we verify and confirm that the layout that we have matches what exists in the environment. So assume you looked at the layout and found two rooms here. But once you have visited the site, you found that the customer wiped out this wall and created one bigger room. So you have to take that into consideration while you are designing. You shouldn't include actually a wall here. So you see that wall drawn here? You need to delete it if you found that it's wiped out. So we visit the site in order to confirm that what we have in our model in Ekahau matches what the customer has inside. This is the first target. The second target from visiting the site is to measure the exact attenuation value introduced by a certain material type. For example, let's get back to Ekahau. Let's take, for example, this room. This room has a window here, but we assume that it is a thick window with 3 dB loss introduced for the signal. Now, once you visited the site, To measure the attenuation of this window, you found it to be introducing 5 dB loss. So here in Ekahau, we don't have a window predefined that introduces 3 dB value. So what can we do? We can actually customize it. We can define our own window, okay, and actually change the dB value that is introduced. We can use different color in order to distinguish, let's say, this window type from other window types. After that, we can draw that on top of our layout in order to get more exact results. So the main difference between the first way and the second one is that the more on-site activities you include, the more accurate your design model will be. Why? Because you don't rely on predefined values, but rather you measure and verify what you have on site and define these as design parameters, then feed them into the site survey software, then produce your design model. The last takeaway here is that the accuracy of the RF predictive survey will not be the same once you install the access point inside the coverage area. That is because we're still in the prediction phase. We don't really measure the actual propagation of the RF signals coming from the access points. And that leads us to the need for a more accurate approach, which will be discussed in our next section. It is the on-site RF survey. Simply, you need to go on-site in order to design Wi-Fi. As you can see myself, I was in one of the facilities equipped with the right design tools, a site survey laptop with a site survey software and a survey adapter, plus an access point mounting kit. It's called AP on a stick, where you will have your access point mounted on top of the pool with a battery to power the access point up. So this method is a combination between hardware and software. I use Ekahau Site Survey as the software plus these hardware tools. It is done completely on site and it produces actual or accurate results because you measure the signal propagation inside this area from this access point. Nothing is predicted. Now, in order to perform an on-site RF survey, after you decide which tools you need to use, you need to have your access point properly configured with the right RF settings, such as the transmit power, the channel, the data rate, the SSID, etc. And you need to tune your adapter to look after these settings. After that, a thorough site walk will be performed that spans every square meter inside the coverage area or the area of interest, where we can extract the signal strength for the signals coming from the access point. By this, we will have an actual coverage pattern and model for this environment using this access point model. Now let's take a quick comparison, take a look at a quick comparison between the two methods. In terms of the survey efforts, it will be higher while you are on site. The same case will be applied to the cost. So basically for on-site survey, you need to buy extra hardware. And once you charge your customer for the service that you are going to provide, you will charge them higher than the predictive survey. Both the access point placement and the cable installation will be accurate and exact for on-site surveys, while these two requires some extra work and shift in order to get the job done. The cell coverage in predictive, it's predictive, so we estimate things. But while we are on site, we measure the actual cell coverage. And last but not least, the use cases for the two methods. For the predictive survey, it comes in handy once we have inaccessible locations or once there is a vendor or partner that wants to estimate the number of access points that they want to sell for their customers. So they estimate what we call bill of material using the predictive survey. On the other hand, for all enterprise Wi-Fi projects, on-site survey is the recommended approach. Now, for the sake of having fun, I have added a snippet for a well-known joke. Let's read it together to understand the message out of it. This is Ashur. Ashur knows the difference between off-site and on-site Wi-Fi design. Ashur doesn't use predictive modeling. Ashur goes on-site to design Wi-Fi. Ashur is smart. Be like Ashur. I think the message is super clear, except the fact that Ashur is smart. I really doubt about this. I don't think so. And that's it. That wraps up our first part of this video series. Up until the second video, thank you for watching.